Hello, everybody. Thank you for joining today's Darcy Live event. My name is Sammy Sultan, and I'm excited to spend the next hour with you all talking AI and unstructured data. This is where you'll be able to find today's content, see the event recording on Monday, and just really have the ability to connect with our speakers after the session. For today's agenda, we have NarrativeWave walking us through their solutions on unstructured data, followed by a discussion with Denbury on how they've personally leveraged NarrativeWave for their operations. We'll then conclude with some good Q&A, hopefully. And if you navigate over here to the content tab, again, if you're unfamiliar with our event page, you'll find copies of today's presentations that you can follow along today or even just review after the session if you didn't make it. You'll also see the recording that will come up here again on Monday. Now, for those unaware, NarrativeWave is one of the leading AI providers in oil and gas today. And without divulging too much and stealing their thunder or anything, their natural language processing technology and platform really allows operators to just make better informed decisions across the value chain, whether it's from exploration or environmental compliance or anything in between. And we've already heard from several positive use cases just from other operators using NarrativeWave, and just given the excitement around NLP today, it only makes sense to just share what they can do with the rest of the industry. Now, today we're going to hear from several speakers from the Narrative team, including Benjamin Desio, the CEO and board director. We have Shelley Buckland, also the senior director of client success, and then Aaron Almada, the data scientist. We also have the pleasure of being joined by Jonathan James of Denbury, who is the manager of digital transformation and emerging technologies. Now, before I hand it off to the Narrative team, I want to launch our first poll of the session on Gen AI, just to dive a little bit deeper into NLP. This is a hot topic. Want to see, what the rest of the industry is doing. And that should be coming up on your screens now. And as that's coming up, I'm going to go ahead and hand it over to the team. Benjamin, Shelley, Aaron, floor is yours, and you're welcome to start sharing.
Yeah, thanks for that amazing intro, Sammy. Great. Well, thank you so much for being here. I'm super excited to get things kicked off and talking about how you can leverage unstructured data for actionable use cases. Now, like Sammy said, we have a lot of speakers today, a lot of really cool information. So I'm super excited for you all to hear it. So go ahead and move this to your big screen. You're going to want to pay attention to the whole thing because it's going to be really robust and informative and hopefully a little fun as well. So without further ado, grab your popcorn and your jujubes and let's get going. All right, so my job really is to lay the groundwork and really help give an overview of unstructured data to really set the stage for understanding the use cases that Aaron and JJ are going to talk about. So first, what the heck is unstructured data? Well, I'm glad you asked. Unstructured data is data that doesn't have a predefined structure. It's very difficult to organize and search because of that. It comes in various forms like text, images and video, and audio. And here are just a few examples of how you're using unstructured data in your daily lives now that maybe you don't know. So for example, email, you can see that there's some AI pre-populated responses here. Essentially, AI is reading your emails and offering suggested responses. Images and video, we can see these on our phones often now where it's saying, hey, is this the same person? The AI is trying to organize the data for you. And then in audio, oftentimes we can use different apps to say, hey, I want to know what this song is, and it will listen to the song lyrics and actually tell you what the song is. Now, unstructured data, to really, again, set the stage for how to sort of the lens to see the rest of this presentation. Unstructured data and structured data work together. Now, I'm going to put this in the most simplistic form. So let's say, for example, that you stay at a hotel. That hotel then sends you an email and says, hey, how was your experience? It provides two options to answer. One is a dropdown. How would you rate your experience from 1 to 10? You have a dropdown and you can pick 1 through 10. The next question is, what would make your experience better? And it's an open text field. So the dropdown menu, that's your structured data. The free text field, that's your unstructured data. Now, how does the unstructured data make your structured data more robust? How does it help you put it into context? Well, if you answer that your experience at the hotel was a 2, the hotel knows that your experience was pretty awful, but they have no context of why it was awful. Bring in that unstructured data from the text field. You could say my stay really sucked because my hotel room wasn't clean. The hotel now can use that unstructured data to make that 2 meaningful, and they know where to focus their attention. Now, it's estimated that 80 to 90% of all data is unstructured. That's a huge portion of the data that your organization has. Now, until recently, it was really difficult to get any type of insights from this data because it's difficult for a person to sift through this massive amount of information and figure out how to get meaningful insights, certainly on the breadth of the data and on any type of consistent basis. Now we have advanced softwares like NarrativeWave that can use AI to pull out insights from the data, which is really the way of the future because, again, more companies are wanting to use data that they already have, use what they have at their disposal. And 80 to 90% of the data unused, that's massive. So the way of the future is using what you have and really tapping into the insights from the bulk of the data. Now, like anything, there are challenges of using your unstructured data. One, it's difficult to process and analyze. Again, humanly impossible for, to sit down and try to go through 80 to 90% of the data that you have and from a consistent basis, really pull out insights from that data. So it requires advanced techniques like natural language processing, machine learning, AI to really process and analyze that data. Because the data has a lack of structure, it's really hard to save the data in any type of consistent format. It's hard to organize the data and retrieve the data, again, because there's just not much structure to it. The data quality can be inconsistent. There's a lot of different types of data when we're talking about unstructured data, and it's likely going to come in a lot of different formats. It's going to be, not a lot of stability in the way that you're getting the data. Now we think, forget square peg, round hole. You've got a round hole with pegs of all different shapes and sizes that you're trying to put into that round hole. And finally, it's complex to interpret. Because it's unorganized, it makes it really difficult to find value in the data. But there's enormous benefit to using unstructured data. One, you get to unlock new insights. Again, the majority of your data that's being generated is unstructured. So you're tapping into a data, this massive data mine, if you will, that you previously could not get to. Now, if you think of your organization like an iceberg, for example, the little bit of the iceberg that you see above the water is your structured data. The bulk of the iceberg under the water, that's your unstructured data. So if you're not using your unstructured data, you're making decisions of your organization of that entire iceberg from just a small representative sample of your data. So now, by using that unstructured data, you can make decisions for your entire business or that entire iceberg because you truly have a representative sample of data. Enhanced decision making. Because you have all of this knowledge, you can now make better business decisions because you have that additional context. Now, reducing workload on your employees is huge. I have seen situations where it's one person's sole job to sift through unstructured data. Think daily reports, sifting through all the different comments and trying to compile those into a summary report. You can automate these tasks so that you're reducing the workload on the employees. And finally, it gives you a competitive advantage. Now, it's estimated that only 30% of companies are actually using their unstructured data because it's challenging, right? It's easy to think, how in the world is this even possible to use this data? So if you are using this data, you are already automatically have a leg up just by simply using it. Now, the path to using unstructured data, this is going to be a very high level. JJ and Aaron are really going to talk about the operational aspects of this, but from a high level, there's really 6 steps from taking your unstructured data to actionable insights. The first one is set the goal. Now, you need to decide what you want to get from using your data and, what problem are you solving? That's the question really to ask. And the reason is because you have to figure out what data you want to use. What data can you pull from to solve that problem? Because there's a vast amount of data. So you want to hone in on that. Number 2, analyze the data. What can these data sources tell you? And that's really going to help inform what your outcomes can even be. Number 3, organize the data. Unstructured data, lots of different formats, living in a lot of different systems. Really organize that into a central location, whether it's a data lake or something like that, some sort of data repository, so that the softwares can easily pull the data. Standardizing the format. This is really key because standardizing the format of your data is going to allow your model to seamlessly run across your data and really provide insights by pulling in as much data as possible. Now, this is going to involve things like standardizing the text, for example. So basic example, how many different ways can someone type or write the word workover? Is it one word? Is it 2? Is it a capital W? Is it a capital O? Are they abbreviating it? W-O, W.O. So all of these different things mean the same thing, but you need to standardize that all of those things mean the same thing. Next, run the model. So the work really is done. You're going to input the data into the model and you're going to run it. And that's where you're going to get the outcomes in an easy to digest format where you have the value and it's easy to understand. Now we're focusing, heavily on one use case today with Denbury, but the reality is there are so many different ways that you can use your unstructured data. Now I'm not going to go through these in depth and bore you, death by text here. You'll have access to these slides, and certainly if you want to talk more through any of these or any ideas that you have, we're happy to do that. But just to highlight a couple of different things like contract management. Again, I know of an organization where it was somebody's sole job to go through these massive contracts, pull out things like cost center coding, important dates and contractual guidelines. You can automate that through use of AI and advanced softwares. Things like enterprise asset management, really key here. We have technicians going out into the field. They're putting in notes of what they're seeing and what their experiences are, but we're not relying on them. In reality, those notes are probably going to give us the most detail or more detail than just the information of why they went out there and what was fixed. They're going to tell you important issues that they're seeing or important context behind the failures, why they were called out there. So rely on that to really help you make more robust decisions for your fleet and for your business. So again, just really want to drive home that there's so many different ways that you can use unstructured data. And again, it really helps your structured data to provide meaning to that structured data. And that's it from me. Now we want to send it over to Ben. Is Ben on, Sammy? Okay, no worries. So I'm going to go through, this will be much faster then. But I'll run through Ben's slides real quick. So a little bit about NarrativeWave before we get into the meat of the use cases, which is really why you're here and what we really want you to hear. So NarrativeWave is an advanced software platform, advanced analytics platform. We operate across 7 energy sectors and manufacturing. Really how we work is we deploy custom analytics. We really take the data, we develop custom analytics and workflows. We implement internal workflows to help you resolve the issues from issue notification to resolution. And then we take your feedback from your subject matter experts, the people in the field who are actually doing the work, to make the system better. Now, there's a lot of different users who can use NarrativeWave. We are built to accommodate all the users, all the way from C-suite down to the field technicians. Everybody can use NarrativeWave to get the insights that are meaningful for them through things like machine learning, advanced monitoring, generative AI, etc. And just some different use cases we do. Again, I'm not going to go through these in depth. You'll have access to the slides, but things like predictive maintenance, failure prediction, process automation, understanding how operations are affecting your asset degradation. And then we have some advanced use cases. A lot of these are oil and gas, like production deviation and optimization, curve analysis for maybe your ESP pump curves, understanding how you're operating and if you're operating in the most efficient and effective manner, emissions, compliance monitoring, those sorts of things. All right, and that's where I'll end, and I'll send it over to Aaron.
So, hello everyone. My name is Aaron, and I'm a data scientist at NarrativeWave. Currently, I'm in charge of the Denbury account. Today, I'm going to tell you more about the Denbury use case, along with other applications and visualizations the account has in our platform. So, the main goal of using unstructured data in this project is to be able to understand the job summaries. The job summaries are the daily descriptions of what was done by the contractor when doing a job on a well, and normally it comes as regular text. 3 different types of jobs were selected: tubing, casing, and road. So the first step is to load the data into our system. Using this data, an AI model was trained to read the text on the job summaries and give us a price prediction. Based on these predictions, we can determine if the actual pricing of the contractor makes sense or not, if it's too low, if it's too high, thus giving us a cost insight that we can visualize inside the events and other notifications. In just a moment, Jonathan will show you this really cool and advanced function that we offer called events. And for those asking themselves, and how do they manage to load the unstructured data into their platform? Because it's complex. Unstructured data is messy, it's complex. So how do we manage to put it here in the system? Well, I must say that our system is pretty flexible, and it allows us to use any technology or any method that we consider to be the best option. In this case, we have an extractor that connects to an SFTP server and extracts the unstructured data inside a tabular format. So yeah, in this case, the text is inside a table. However, depending on the use case, other formats can be used without any problem, such as JSON files, dictionaries, text files, and many others. Even PDFs can be loaded with the right technology, of course. After extracting the data, we upload the information into the cloud and perform the required transformations, just as Shelly mentioned, the normalization, that transformation, so we have the data ready and usable. Finally, we load it into our system so it's ready to be used for whenever it's needed. Here, we can see the ETL process we follow inside an automated task that runs daily. So in here, we can see the extraction, the transformation, the load into our system, and also the automation here on top that runs daily. Yeah. The screen you're seeing right now is called Data Explorer, and this is really cool as it allows us to interact and visualize the data that is loaded into our platform without the need of any code or configuration. Just clicks, that's it. So basically, you only have to select the asset you want to visualize. That's what it's doing, what it's been doing here. Then you must select the variables you want to see. You can select one or more than one. Then you select the data resolution. In this case is 1 hour, the time frame. So in this case, last 7 days, and click plot. That's it. That's how simple it works. And this makes it really easy and fast to visualize any asset and any variable from the thousands we may have available in the system. Here we can see the resulting plot that was created, as I mentioned, just with some clicks. As you can see right now, our platform is capable of having powerful visualizations. This one from the top is text, so we can add text, explanations, and whatever description we need without any problem. You can also add plots, different types of plots. In this case, we have bar plots. And also, it allows us to add extra information when hovering the mouse over it, along with many other functions. Just want to clarify that everything is personalized for the need and the requirements of each customer. So yeah, all you're seeing here is completely personalized. In this other screen, we can see advanced analytics, which is a key part of our platform. In here, we created some KPIs, line plots, and machine learning forecasting. So behind these line plots that may look simple, there's an advanced model predicting future values. We can turn on or off the variables depending on what we want to see, and also we can zoom into them. And here, the purple line and the red line are the forecasting predictions. So these are numbers that we don't really know, and we are forecasting or predicting into the future. And the blue line is giving us the training values that we use to train the model. This is another visualization also of a forecasting line plot visualization. In this other screen, we show different types of plots that we can also add into the system. First, we can see a bubble plot. This is really interesting because it allows us to visualize 3 different parameters in a 2-dimensional plot. We also have line plots that shows different pressure behaviors in the same timeline, like in here. So every line is a different timeline, but we're putting everything together so we can visualize together. Also, we can turn on or off the variables. We can hover the mouse over it to get extra information. We can zoom in, and we can do other types of functionalities. Finally, we have a table that shows information in a tabular format. Of course, beside these examples, you can add more complex visualizations. This just was an example, like scatter plots, maps, box plots, heat maps, and many others that you may need. So the platform is flexible enough for us to create any visualization and to load any data that is required to create analytics that can actually provide value to you and your team. Well, that's it for me. Thank you for your time. And now we go with Jonathan. Thank you.
While Jonathan is pulling up his screen, just want to encourage everybody. We already see a few questions in the chat. Please feel free to continue putting your questions in your chat, and we will get to them shortly after Jonathan's session.
All right, I'm Jonathan James. I've been with Denbury for about 12 years, backgrounds, production engineer, and then moved into my current role about 2 years ago, focusing on digital transformation and technology projects. So I know NarrativeWave gave some background on kind of challenges and upsides of unstructured data, but thought I could maybe provide some more context with how I look at it with oil and gas. So as a lot of people are probably familiar, we've talked about well work, and that's kind of what we've focused on for our use cases. But just an example here of a report that's utilized by rig foremen and engineers to review previous work history. So each one of these sections here is a job summary for that well. So they would want to review it before they get on that well. And that's going to be useful before getting on that well, but there's going to be a lot of valuable information in those job summaries, or even the daily summaries that we would want to aggregate so that we could learn to apply the lessons learned, or how we problem solve and what solutions work best for us. And as we try new things, like for example, one of the job summaries is that we had a rod part. We wanted to lay down the 1-inch rods, and we replaced them. So when I would look at replacing tapers, usually kind of the rule of thumb was, okay, third rod part, you'd want to replace the taper. But is that necessarily the best business decision? Would you replace it just mainly after a year? What kind of insights can we get with the unstructured data that a design change was made in the unstructured data, and then apply it to the structured data about run times, costs, and make those better decisions. So as the valuable insights are kind of lost between all the standard kind of jargon that we put in those summaries. And then this is a project that's a typical intern project, right? Where you give them a bunch of well view data, they export it out into a spreadsheet, they go through it, probably just using common search terms to understand what was done. All that analysis is going to be, you're going to have to trust that they did all the analysis correctly, right? A lot of room for error when you're doing that. And not very transparent. No one's going to sit down and kind of walk through how they did everything, and they're not going to want to update it, right? Because then it's pretty much the same amount of effort to update that analysis. So upside, of course, as Shelley mentioned, we have a lot of it, and how useful it can be. So her example with the hotels, right? So the two out of 10 doesn't mean much, but what's really valuable, and if you've ever done surveys yourself, what's really valuable is that if people actually take the time to enter in text. So in addition to that, the information that is being input in that in unstructured format is going to be some of our most technical people, right? So either the people out there who are actually looking at the job, what went wrong, or the people who are doing the root cause failure analysis, right? So typically you've got the when and the where, what happened, sorry, when did it happen, where did it happen, right? That's going to be structured data. That'll be your functional location SAP. But kind of the how it happened and the why it happened, that's going to be more nuanced. You know, you're relying on your technical people to provide a summary on that. You're likely not going to have subject matter experts who are going to select from a pick list about why it happened and how it happened. And then really the upside too is that it's accessible. You know, for workover data, you know, I can easily pull years of data. It's low frequency data. You know, put in a CSV file. We can pass it along to NarrativeWave, which is, of course, who we've used to leverage this data and their skill set to do the analytics. But you know, we can spend an hour or two to try to provide our use case, and they can dig into it and see if there's something worth moving forward to automate those daily uploads. So honing in on the use cases. So of course, involving the subject matter experts. You know, looking at this action priority matrix, which is a good way of, you know, just thinking about how we, you know, what we spend our time on. So thankless tasks, that's, you know, that's that unstructured daily input data for those reports, right? People are spending hours and hours and hours inputting that information for it to be reviewed, potentially on the weekly report, just the reports when the job's active, or then maybe that report whenever they're about to get on the job again, right? So can we leverage that historical information to provide quick wins? So, you know, using subject matter experts, kind of the main things that I focus on are, can they identify, you know, those thankless tasks that they're running into, whether it be, you know, like referencing PDFs for, you know, equipment specs, or you know, looking at more aggregated data to have to do on their own manually, and also, you know, what they want to automate, you know, and then also probably the most important thing is you find people who want to collaborate with peers. They want to share information. They don't look at knowledge as, you know, as a resource that they want to hold on to, and they want to be able to train some, maybe the less experienced technical people, and also working with the less experienced technical people, ask them, you know, they're in meetings with those more experienced subject matter experts, or do they find that, you know, what are those experiences, what kind of solutions do they see subject matter experts providing that are mainly based on experience rather than, you know, say, an aggregated data set? And those maybe less experienced subject matter experts would want to see that aggregated data and learn from it. And of course, prioritizing projects that can be communicated easily. You know, I've learned that in this job quite a bit. You know, because a lot of people aren't familiar with some of the ideas or technology that's out there, making sure that it's a elevator pitch ready. You know, of course, aligning with corporate strategies, making sure that you're starting that elevator pitch with solving a corporate strategy or corporate issue, and then of course delivering quickly. All right, so getting into our use case. So this was really our first step to understand, you know, how can we utilize our daily job summaries. Aaron mentioned it, that the natural language processing, can we start monitoring the daily job summaries to track and estimate costs, you know, how expensive should that day have been based on the actions that were completed, and also what's been done, right? You know, can we identify, okay, are we 50% done the project after today? Do we only have one more day to go and we're you know, below AFE? So, you know, previously we really rely on AFE estimates, which of course are potentially on capital projects months old, right? But we would like to see something maybe more updated. So the trend there you see, so we use the natural language processing model. We come up with a well profile. There's certain drivers that would, you know, kind of make the model a little less accurate. So we've worked on identifying those. And you can see we've got a cumulative intangible price. So that's going to be our field estimate, the cumulative tangible price. So we did learn you know, we have to take out the tangible prices. You know, you're not going to be able to really identify your tangible costs using your daily summaries very accurately, and then your cumulative predictive costs, and then also compare that among the field mean. So we utilize that, and I'll get into a demo to show here. So just kind of scrolling down the events list here, the blurred out, your eyes are fine. It's just blurring out some of the information. So I'll pause it here. So just looking at the columns, so you can get in here. Active, those are of course your active jobs, workflow. So you can send these, mark them as reviewed, you know, kind of based on maybe the key value. Key value over here is going to be that variance from model to cumulative model versus cumulative actuals, and then the event type. So you can sort them, of course, by column headers, all the events. So as we started building the model and start identifying, you know, maybe what key drivers or metadata that we would want to start including on the jobs, you know, we wanted to start doing that so that we could filter them and, of course, make the model more accurate. You know, depending on what kind of well it was, and all the other filters that you see there, date range. We'll go into one of the events here. So this is the information that we decided to include on the event. Scroll down, you can see the most recent operation summary. And then the cumulative predicted price and the cumulative model price, and also the most recent price and most recent days model price. And then just a tabular format for the total daily intangible prices. And then the trends here showing kind of your each day, what your predicted price and your intangible prices were. And then you can scroll in, which is helpful. And, you know, for a day that has a big variance, you can just highlight, or you can scroll your cursor over it and read what the summary was for the day. And then the last trend is just the cumulative look at that. So this is a pretty big project. It looks like there was likely a scope change. And, you know, as we ran into these, that kind of leads me into my next use case. You know, as you know, since that that scope change occurred, you know, the model's not going to really provide very much insight moving forward, right? So what we thought of was, you know, a typical scope change that happens that, you know, costs us a lot of money, and that's casing leaks. So just my little decision schematic here on the right here, if you can follow along with me. So job objectives, say you get on a well for a tubing failure, right? You've got a pretty easy procedure, say, you know, 4 main steps to reach your proposed ROI to spend the money on this well. But you get on there after, you know, your step 1, you understand that there's a casing leak. So there's a few options, right? You could try to squeeze it, and let's say we've got a high likelihood of being able to squeeze this casing leak, repairing it, and then we move on. You know, we spent the extra money to squeeze and repair the casing, so little lower ROI, right? Maybe another option is there's also the more expensive option, maybe running a liner in this case. So you do that and then you move on. So it being a little more expensive, smaller ROI. Of course, if you know, equal likelihood of success for these scenarios, of course you're going to go with the higher payback, right? But you know, that's not real world. There's going to be all these items that might make you decide to run a liner, and you know, we currently do that based on experience, right? So say you find out some of the details of the leak, that it's a very big leak. Maybe you have more than one leak, or just, kind of your success in this field where you just don't squeeze very successfully. So maybe you start looking at just running the liner because you know that the likelihood of success is higher, and you don't want to risk the chance of trying A, B, and C, and also having to do big A, and then maybe you have a negative rate of return, and you're not going to make money on the project. So kind of our idea here was to leverage our historical casing repair history, and having prescribed scenarios that would provide our success of likelihood based on kind of how we plan on repairing it, what that cost estimate would be, and then update our project economics so that we can get together and kind of have all those scenarios out in front of us. So kind of currently where we are on that. So we've gone through and used the model, the NarrativeWave model, identifying casing leaks. So right now we have kind of a curated way for rig foremen and engineers to access casing leak history. Right now they would have to go in and review the job summaries. We have done some work to highlight the keywords in the job text so that they can identify, the casing leak details, the repair attempt, and then the testing, right? So kind of second step here is we want to start capturing the details of the casing leak out of that unstructured data, right? So we would identify where, the depth of the casing leak, the injection rate of it, that type of information that would currently maybe drive the engineers and the rig experts to a certain repair attempt type. And then also identifying the repair attempt. So if it's a squeeze, did we use certain additives with the cement? How much cement did we use? Evaluate those impact drivers, work on doing the analytics to understand the likelihood of success for the repair types. And then kind of that third step that we want to get to, like I mentioned, is having a model that prescribes the repair types and provides us just kind of the math that shows us that we're making the best business decisions. So a little quick demo here of what we currently have access for anybody who's wanting to search casing repairs. So we've got outcome, well name, field name. So you can, if you're in a certain field, make sure that you're only looking at casing leaks or successful casing leaks in your field. And then I mentioned the just highlighting certain keywords for everyone to be able to use. So, trying to unlock the ability and the ease which people can access that information instead of, basing their decisions on how to repair something based on just personal experience. So that's all I have.
Thank you so much. Thank you, NarrativeWave and Denbury. We will see you at our next session on April the 3rd on tracers. Till then, have a great rest of your day, great rest of your week.